Oh my.
What are we going to go over if there's just 3 juniors in here?
Nothing.
What? Oh, yes, I can't
We
wait.
should space it out like one lesson a week.
This is why they should let juniors take senior classes. I'm just kidding. I'm actually really glad I'm in here. I would way prefer it over trigonometry.
I took that.
Alright, first thing we've got here, this is the formula for the area of a circle. Area equals pi times the radius squared. We're going to solve that for r. Okay? We've done this type of lesson before where they give you a formula and they ask you to solve it for a different variable. Only deal with it today is they're quadratics. They've got squareds on them since we've been doing quadratic stuff. So right now, first thing I do, if I look at the r, it's being multiplied by a pi. So undo that. We're going to divide by pi. So that gets me a divided by pi is equal to the radius squared. Okay, good. We're trying to solve for r. It's being squared, so they were right over here. They said square root it. So to square root the squared on the r, it cancels out. So I'll just have r equals. When I square root the a over pi, that means that I have to square root the top and the bottom. And that's where our dilemma comes in. We can't leave a radical on bottom. So what can I do to get rid of that square root on bottom? No. It's a square root of pi on bottom. So good. Multiply it by the square root of pi. Okay, so on the top, I've got the square root of a times the square root of pi. I don't really know what that is. That's just the square root of a times pi. On the bottom, square root of pi times the square root of pi, that's actually the square root of pi squared, and then the square root of the square cancel out, so you just have a pi on bottom. Okay, is everything satisfied? Do I have the r all by itself? Yes, so that's good. Did I get rid of the radical on bottom? Yes, so that's good. So there's your answer. I do need to add one thing. I just looked at the book. One thing I forgot. Does anybody know what I forgot? Very good, Blake. Plus or minus. When we do square roots, it's got to have that plus minus in front of it. Alright, let's try another. Got what you need on that page? Here I've got S is equal to 30 times the square root of a over p. We're going to solve this for a. Alright, so what should we do first? Any guesses? Trying to get the a all by itself. Got some extra junk there. Not yet. Good, Mr. Scout. It's being multiplied by 30, so we're going to divide by 30. So I'm going to have S divided by 30 is equal to square root of A over P. Yes. Okay, what Angie's noticing now, this whole piece is underneath the square root. So I'm going to get rid of that by squaring the whole thing. Okay, so when I square here, that means I got to square top and bottom. So it's going to be S squared over 900 because I squared the S and the 30. And then I've just got equal to A over P. Very good. Now your A is being divided by P. So you're going to do that by multiplying by P. So I'm going to have, and you can put it in any order you want. When I got crazy variables like that, I always put them alphabetically. So I'm going to have P S squared over 900 is equal to A. If you put the S squared first, that's okay. It's because multiplication can go in any order. I just always do alphabetical for some weird reason. Alright. Everybody all right on that? This next deal that we got is where it gets a little bit crazier. It's pretty simple still, but just something totally new for us. I got 2t squared minus 5t plus k is equal to 0. We're solving this for t. Alright, looking at this, the equation that we have and the variable that we're solving for, what does that look similar to that we've been doing recently? Quadratic formula. That t is what's in the x spot, right? So all I'm going to do on this is use the quadratic formula. Okay, so this would start off here. My a would be 2. My b would be -5. My c would be k. Okay, so instead of x equals, these are t equals -b plus or minus square root b squared minus 4ac all over 2a. I'm not going to be able to simplify that a whole lot, but I can a little bit. Good. I got t equals 5 plus or minus the square root of 25 minus 8k. That's the 4 times 2 in there. Now, do I know what 25 minus 8k is? No, because they're not like terms. Do I have t all by itself? Yes. Do I have a radical anywhere I'm not supposed to? No, so it's good to go. If I could have reduced the 5 over 4, I would have, but nothing common there. The book wrote that out twice, which is a lot to write in my opinion. They wrote t equals 5 plus the square root of 25 minus 8k over 4. And then they wrote t equals 5 minus the square root of 25 minus 8k over 4. That's a lot to write. I use the plus minus sign. Not too shabby. Alright, now we got a couple of scenarios where it's a word problem with some formulas that we know from previous usage. So, I got what you need there? Alright, it says a ladder is leaning against a house. Okay, so you've had those problems a million times. What's going to be involved if a ladder is leaning against a house? Pythagorean theorem and a right triangle. Very good. So I'm going to draw my right triangle. Okay, this hypotenuse, this longest leg here would be the ladder. This will be the house, and there's your ground distance, right? And so it says the ladder is leaning against the house. The distance from the bottom of the ladder to the house, so the bottom of the ladder to the house is 5 feet. Okay, the distance from the top of the ladder to the ground is 1 foot less than the length of the ladder. So this is 1 foot less than the length of the ladder. How tall is the ladder? I don't know. And then this one's 1 less than that, so it would be x minus 1. Okay? Now what Austin said is right on how we're going to set this up. This is a right triangle, which is your Pythagorean theorem. So I'm going to have a squared. You can use either one. I'll do the 5 first. 5 squared plus b squared equals c squared. Hypotenuse is always your c. Now with that x minus 1 squared, you have to write that twice and FOIL it. So I have 25 plus, let me do it up here, it's x squared. And on your outer and inner, you get negative 1x on both of them, so that's negative 2x. And on your last, that's plus 1. Okay. Well, yeah, but first I see I got a like term. 25 and 1 there gets me 26 plus x squared minus 2x equals x squared. Alright, now it's not set equal to 0. So I need to set it equal to 0. And good. And that's good news because when I do that, it cancels out. So I'm just going to have something linear. I got 26, that's gone, minus 2x equals, there's nothing over there.
0.
Yep, yep.
That'd be negative 2x equals negative 26.
Okay, Austin moved the negative 26 over. That's fine, I'll do what he said. He subtracted the 26. When I did it earlier, I added the 2x, but we're still going to get the same answer. So either way would work. Now you know what you got to do. Divide by negative 2, and x equals 13. So that's an odd height for a ladder. Maybe they've got it adjusted and they're measuring that. That's not the height you go to Home Depot and buy. So the height, the length of our ladder there is 13 feet, which means our house is 12 feet. And they already got it. Yeah, that's what I'm saying. They've got it extended and measured it. That's not pretty cool. I like those kinds of problems.
I was pretty good.
You'll marry that.
Yeah, and they make common sense.
Yeah, what comes in that up there, don't
Did she say except 2 plus 2? Okay. Got a pool in this problem, so we got another real life problem. A pool in most occasions. I know there's specialties, but this one is not a specialty. It's going to be a rectangle. Alright, it says a rectangular reflecting pool in a park is 20 feet wide and 30 feet long. So I got 20 feet and 30 feet. Okay? The park gardener wants to plant a strip of grass of uniform width around the edge of the pool. She has enough seed to cover 336 square feet. How wide will the strip be? So let's see if I can use the fancy tools and make a rectangle around that. Get a little bit bigger and then I'll scoot it. I don't know if I can get it uniform width or not, but we'll try. Oh, it's not bad. It's not bad. Alright, so what we've added onto the edge of the pool, you've added a distance there of x and a distance there of x. So when our pool was 20, this grass strip we added 1x and 2x. So it would be 20 plus 2x. Same thing on the length there. We've added an x on that end and an x on that end. So while the pool is 30, we added 2 x's to it. So that grass is going to be 30 plus 2x. Okay? So what we've got to do here, first off, what's the area of the pool? Just the pool. 20 times 30, so it'll be 600 square feet, right, of just the pool. Okay, so I know I'm only going to put grass around the edge. I'm not going to pour the grass seed in the pool. That'd be dumb, right? So whatever, when I start going here, I'm going to have to subtract the area of the pool out, right? So if I can find the area of my whole big rectangle I've got and subtract the area of the pool out, that would be what was left for that edge, right? So I've got 20 plus 2x, area is length times width, times 30 plus 2x, minus 600 is got to be equal to, they told me how much grass seed I had. Let me read that to you again. I got enough seed to cover 336 square feet. So that's going to be equal to 336. I'm kind of all jumbled up in my picture there. Let me circle my equation we're looking at. Alright, kind of looks like the giant diving board in the pool or something. I don't know. What do we need to do to start simplifying this? Foil those binomials. So that's 600 plus 40x and plus 60x is plus 100x plus 4x squared minus 600 is equal to 336. Hey, your 600s, you don't got to mess with those. Got a positive one and a negative one, so they cancel. So all I need to do now to get it the rest of it in standard form is bring that 336 over. I'm going to put them in standard form order as I do that. So I'm going to put the 4x squared first. 4x squared plus 100x minus 336 is equal to 0. Okay, You can go from there and do the quadratic formula with that, an a of 4, a b of 100, and a c of negative 36. You know that I like smaller numbers because I like to be able to do them in my head. So what I noticed on this is that I could take a 4 out of all of those. So I rewrote that. I divided it all by 4, just reduced it. It got me x squared. 100 divided by 4 is 25. And then negative 336 divided by 4 was negative 84. Now, 84 is still a hard number to work in your head. This one actually will factor. So you can try to factor it if you want to, or you can do the quadratic formula. I'll do whichever one you want to do, but you're going to have to help me if it's quadratic formula because I don't know 84 in my head. So, what do you want to do? Factor or quadratic formula? Factor. Heard that first. A times c is negative 84. I'm looking for factors of negative 84 that add to 25. Okay, you know it can't be 1 and 84. You know it can't be 2 and 42. What about 3? How many times? 3 and 28. Hey! Okay, to make a positive 25, I would need the 28 to be negative, or dummy, 28 to be positive, and the 3 to be negative, right? Yes. So I'd have x minus 3 times x plus 28 is equal to 0. Alright, this is easy schmeezy here. Set both of these equal to 0 and solve. If x minus 3 is equal to 0, you get 3. And if x plus 28 is equal to 0, you get a dummy answer. Why is negative 28 a dummy answer? Right, remember what x stood for. It was how wide we were making that grass strip around the pool. You can't make it a negative 28 feet wide. So that's out. So our grass strip has got to be 3 feet wide. It was a little bit more involved than the latter one, but I still like that. And I did the quadratic formula and she's getting the same thing, it looks like. Get your positives and negatives backwards. I should get your positives and negatives backwards. Quadratic formula works as well. Alright, just got one more type. This one was a lot shorter than yesterday's. One more type of problem to look at real quick. I like these. This is about when the object goes up and comes down. Because you know, if you think about any kind of object that goes up, if you kick the ball, it goes up and comes down. If you throw the ball, it might not have much of an arc, but it still goes up and then comes down. If you shoot a gun, it might not have much of an arc, but it still goes up and comes down. So all of these things where something goes up and comes down makes a parabola. So they're all quadratics. So here it says a ball is projected upward from the ground. Its distance in feet from the ground at t seconds is s of t is equal to negative 16t squared plus 64t. Okay? At what times being 2, because you know it could be at the same time twice, right? At what times will the ball be 32 feet from the ground? So where will the 32 feet go into our equation? Say it again. No? Right, it'll go over here what we're equal to. Good, Austin. So 32 would equal negative 16t squared plus 64t. Just a side note, what if it said when the ball is on the ground, what would go here? 0 is exactly right. Good job, Austin. So I'm going to subtract that 32 from both sides. So I have negative 16t squared plus 64t minus 32 is equal to 0. Alright, so you can go with those numbers if you want to. I would divide them all by... I think I can divide them by 16, can't I?
Yes. Oh.
So I'm going to divide them all by negative 16, even better. It's going to make t squared negative 4t plus 2. Is that right? Does 16 go into 64 4 times? Did I do that right? Somebody make sure. 16 times 4, yeah, okay. That seems too easy. Alright, there's the factors of 2 are only 1 and 2, and that doesn't add to 4, so I can't factor it. So it's going to be quadratic formula. My A is 1, my B is -4, my C is 2. Now what would happen if you didn't do that, if you didn't divide them all by 16 or -16? Still get the same answer, you just got bigger numbers to work with. And that wouldn't be bad for you, because you've got a calculator, but whatever. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's easy in there. 4 times 1 times 2 is 8, so 16 minus 8 is 8. So I got 4 plus or minus the square root of 8 over 2. Now, we normally break 8 down. It's 4 times 2, so that would be 2 square roots of 2, right? This is a time when I don't want to know that. Because if you tell me that it took 4 plus or minus 2 square roots of 2 over 2 seconds for the ball to get that high, I don't know what that means. This is a time when a decimal answer would be more appropriate. Okay? In the real world scenarios like that, it's when your decimal is more appropriate. So tell me about what square root of 8 would be as a decimal. 2 point what? 2.83, so I got to do that, and then I got to do that. Okay, so I got 6.83 divided by 2. What do I get here? 3 point.
Sorry, I'm so cute. What is up here?
I still only do the minus one.
3.415.
3.42, then we'll say. All right, Leah, what'd you get on the minus one?
The other one was 0.59 more than the other
0.59. So at just over 3 seconds, and at not even 1 second yet, that ball would have hit 32 feet. Bless you. Those are seconds.
I feel like that's kind of fast.
Yeah, I think so. I think they threw it. I mean, 32 feet is pretty high.
Yeah.
So might have been might have to like did some kind of one of those slingshot things. Might have done something like that. I don't know. All right. Next up on the agenda is inequalities with quadratics. So instead of an equal sign, it'll be a greater than or less than sign. Good news is you know by now you still work them the same way. They just got greater than or less than signs instead of equal signs. Okay? Everybody good?
Yep.
All right.